The notes for today, you really could investigate on your own. So I do invite you to do that. Stop the video. Try it out on your own. See how far you can get. So if we have a Ferris wheel and you and your friend are the last two people seated, you're going to be starting right here at the bottom. Once the ride begins, the wheel moves at a constant speed. Let's just say it's moving counterclockwise like the unit circle. It takes 36 seconds to complete one revolution. So that's important. At 0 seconds when the ride starts, how high above the ground are you? So at this point right here, we're 5 feet. It takes 36 seconds to make one revolution. So 9 seconds is 1/4 of the way. So that would be right here. So how high are you at 9 seconds? Well, that's 5 feet. From here to here is 40, so halfway would be 20 plus the 5, so that's 25 feet. Then at 18 seconds, we'd be at the top. That's 40 plus the original 5, that's 45. And then 27 seconds, we'd be another 1/4 of the way. So that would be right there. That'd be back to 25 feet. And then it's going to repeat. It'd be 5 feet, 25, 45, 25, 5, 25, 45, 25. So back and forth. What height are you at 126 seconds? Well, let's think about that. So 126, whoops. That's, if I divide that by 36, that's 3.5. So that's 3.5 revolutions. Sorry, I am at the school, so the bell does ring. 3.5 revolutions. So starting here, 1, 2, 3.5. So be at the top. We're at 45 feet. Where will you be at 3 minutes? So 3 minutes is 3 times 60. Oh, 3 minutes. Yeah. 3 minutes, 60 seconds in each minute. So that's 180 seconds divided by 36. That's 5 full revolutions. So I'll be back to where I started at. What's the amplitude? Well, amplitude, I could take the max minus the min and half that. Well, the max is 45, the min is 5. So that's 40 divided by 2, that's 20. Now ask what's the midline. In other words, what's the middle height? The middle height. Well, if I'm starting at 5 and I'm going to 45 and I'm going up 20, then up another 20 and then back down and back down. So that 25 is really that middle line. 25 is the middle number, the middle height, 25 feet. What's the period? How long is it taking to repeat itself? That would be 36 seconds. So we want to try to write a trigonometric function that models your height above the ground and the time since the ride began. So this is going to be a good one. Let's start by sketching it. How about that? So 2, 4, 6, 8. Okay, so it starts off 2, 4, 6, 5 would be here. And then, 9 seconds? Oh, why is this graph so weird? I don't know. 5, 10, so at 9 seconds, we are at 25. At 18 seconds, we're at 45. And then at 27 seconds, we're back to here. And then at 36 seconds, we're back here. So it's going to go. This is kind of not a great graph. Okay, so it's doing this, up, down, and then it's going to repeat itself. Yeah, da 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 da. Okay. All right. And so forth. So if I'm thinking about my midline, it goes across like this. And the midline, the middle, was at 25. So that means my whole graph has been shifted up 25. Now if I think about it as sine usually starts right here, right? Well, when am I reaching that point? What time am I reaching that? Well, that is at, that first time I reach that is at 9 seconds. This is at 9 seconds. So I've been shifted to the right 9 seconds. Okay. So I'm going to do this a little different. I'm going to have a function, and this is a function of time, so I'm going to put time. My amplitude was 20. And then sine of. Now here I've got to be kind of careful. I need to figure out that b, that number that goes there. But I know I've got theta minus 9 because I'm right 9, so that's minus 9. I just need this number right here, this b. Okay, so let's think about b. The period was 2 pi divided by b. So if I want to find b, I'm going to switch that around and do 2 pi divided by the period. Well, my period was 36, so that's 2 pi divided by 36. Or pi over 18. Ooh, how far in feet have you traveled after one revolution? Well, you're traveling around a circle. So that's 2 pi r. And the radius of that circle was 20 feet. How far have you traveled in 144 seconds? Well, let's see how many revolutions that is. That's 4 revolutions. So 4 times that distance. Breathing cycles. For a person at rest, the velocity in liters per second of airflow during respiratory cycle, the time from the beginning of one breath to the beginning of the next, is given by this function, where t is the time. Inhalation occurs when the velocity is positive, and exhalation is when the velocity is negative. Let's take a look at this graph. So 0.85 sine of pi, whoops, oh my goodness, I hit the wrong button. 0.85 sine of pi over, I am hitting wrong buttons today, pi over 3 x graph. Okay, so Inhale, exhale, inhale, exhale. Okay, and it does make sense that it is periodic. It goes. Okay, so find the time for one full cycle. In other words, one period. And the period is going to be 2 pi divided by b. And in this case, that was pi over 3. So if I'm dividing by fractions, that's the same as multiplying by the reciprocal. So the pi's would cancel. And I'd be left with 6. So that means 6 seconds. Find the number of cycles per minute. That's 10 cycles. This model's for a person at rest. How might the model change if you are exercising? What do you think would happen? I want you to answer that one and submit it online. Eve is on a swing thinking about trigonometry. No, seriously. She realizes that her height above the ground is a periodic function of time that can be modeled using this, where t represents time in seconds. How high above the ground is Eve after 1 minute of swinging? Let's talk about t is in seconds, so we're talking about 1 minute would be 60 seconds. So we want to know what this is at 60 seconds. So what I could do is I could type that in. 3 cosine pi over 2 times 60 seconds, because that's the t, close parentheses, plus 5. It says 8. So 8 what? 8. It does not say. Let's say that's in feet. What is the range of Eve's heights? Okay, so what is it going to be? So the range, we need the lowest and the highest. So I'm going to have to think about that, how that's going to work. Now I could put this function in the calculator, and let's see, that would be 3 cosine pi over 2x plus 5, and look at the graph, but I'm not going to see it very well in the graph. Well, I can kind of see it. Let's look at the table. Oh, but the numbers aren't pretty. Why are the numbers not pretty? Well, I have my calculator set up to count by pi's over 4, so I'm going to change it to a 1. Okay, that didn't help much. Let's look at the table. 8, so we start at, oh, she starts at 8. Oh, 5, 2, 5, 8. 5, 2, 5, 8. So it believes we're going between 2 and 8. Now I could have also seen that my amplitude was 3. And if my midline's at 5, I'm going down 3 and up 3. And that's all it is to do with modeling.